Okay, so
we resume with 5G KPI, and Pablo will chair.
thank you. So we have two presentations today. And this first one is about the work that we have been doing together in 5G KPI, and it's actually going to be a group presentation. So as you will probably know, in the last plenary meeting in Klagenfurt, so in the last face-to-face physically plenary meeting in Klagenfurt, last summer we organized a workshop on QE management towards 6G networks, let's say. We had a panel, we had a keynote, we had some presentations, and we concluded that the first action point for the team should be writing a white paper, trying to summarize the problems, the situation between the misalignments between the CAPs and CSPs, and also the communication and the multimedia research communities, let's say, and use it as a first step for possible future steps, right? So, in general, I briefly presented the 5G KPI mission Monday, so I will not stop too much here. Just say that this is. So we are really focused on the white paper. We're meeting bi-weekly. It's been a lot of work from a lot of people, right? So these are not just names. All these people had significant contributions to the work, right? So it's a great team that we meet bi-weekly, most of us. So it's a lot of effort put here, and this is the structure of the white paper, which is almost ready to be reviewed, right? So we should be able to release a version somewhere soonish, right? So, and it's also the scope of the presentation. So we'll present the different sections of the white paper, and feel free to ask questions, comments, or things like that, because the more contributions we have, the better for the white paper, right? So with much ado, Shell will start with introduction.
Which you almost have done already. So, okay, let's go. So the North Star of this is to develop a QE/QS model and a framework for QE management in 5G advanced and 6G. So the motivation is to get a more efficient end-to-end video delivery, identify and solve problems seen by the user, an ecosystem win-win approach. It was actually win-win-win approach for CAP and CSP user and the user, and overcome lack of trust and enhance cooperation among stakeholders.
Sorry.
Okay. So Naeem, what did you say?
Let's make sure.
Yes. So in the previous slide, where you mentioned that when 5G advanced 6G, it should be advanced 5G oblique 6G, rather it's yeah, so 5G advanced, I don't know, but it's more.
It's kind of how it's called, like 5G advanced is 5G starting from release 18 or 19, I don't never remember. So it's kind of 3GP jargon, which is horrible, but it is what it is.
So the scope is QA metrics. We will have try to get a clear definition and understanding of the metrics, industry alignment on proposed metrics to use, share and expose, recommendation on standardization framework, and how to measure an action. So an initial focus is on CAP and CSP interaction, acknowledging that other stakeholders exist, generic methodology, but applied to specific use cases. And there will be a start on multimedia streaming and communication of a mobile network, at least 2 services for CAPs and 2 network type for CSP. The framework for information exchange between CAP and CSP. So going for it towards a win-win approach, there has been a high walls between the CAP and CSP. So there are different challenges for the different groups. So the CSP challenges are summarized like the lack of access to QE and traffic types. There are diverse QE targets and QS requirement per traffic classes and wireless products. And reconciling best effort delivery with different fairness, QE requirement and cost profiles of apps, and dealing with new traffic types and services. The CAP challenges could be summarized like the identify network health, congestions, available bandwidth and loss latency, network policies to determine optimal streaming profiles and adaptation and behavior, the opacity to QS impairment, end-to-end view to perform QE optimization. So there is a lack of KPI uniformity and standards among CAP and CSP and between CAPs and the CSP. I don't know what happened. I don't know where I'm at. Maybe here, there, okay. So the issues and gaps. So for the CSP perspective, there are diverse requirements. It is a complexity of policy design and mapping between QS fairness and QS fairness and QE fairness. The lack of QE information limits utility of QS framework, relies on inaccurate inference. Lack of real-time QE feedback, missed opportunity for proactive optimization beyond basic KPIs. So here we have the opportunity via exchange, so targeting QS and QE policies, accurate traffic handling, informed network monitoring and tuning, real-time QE aware actions. For the CAP perspective, it is divided into determining network state, predicting network dynamics and understanding subscriber context. And here are the opportunities via exchange, improve bandwidth estimation, better adaptive bitrate tuning, optimized prefetching and buffering, and efficient data usage. So the use cases that we will or are targeting, we have divided into different categories, the traditional 3GPP applications, which are, for instance, messenger and voice types, and the connected application, web browsing, for instance, online gaming, real-time communication, including video conferencing, voice over OTT, messaging, and streaming media. There we have the long form media, we have the short form media, and also live media. Immersive application could be cloud gaming and extended reality. And then we also have file transfer, which is backup, upgrades, and transfers. So I will hand it over to Pablo to explain this complicated figure, which I don't understand, but okay, go ahead.
Thanks. Yeah, just a bit on the previous slide is that, as said before, we try to be broad in what we do, but we need to be a bit specific. So the things which are in yellow, highlighted in yellow, are the ones which are actually covered in depth in the white paper. So ideally, everything should cover any use case, but in practice, we'll pick a few of them, which should be different enough so that we have better chances that it's easier to generalize later on. And similarly with the network, so this is a bit complicated, but it's not it shouldn't be so much, right? So we have the application on top. So we have a client, maybe with some QoE or QoS estimation, that will get the contents from a server. There might be cache in the middle, right? So that's what is seen from the CAP perspective, but in the networking, there are a lot. I mean, it's slightly more complicated, and its network segment has some different parts. So roughly speaking, the difficult part is the access, which is this part, right? So we have divided between wireless access. So this is why we have a G node B. So this is the base station or fixed access. So in this case, we have the OLT, which is the equivalent, right? So what's the last equipment in the operator premises, right? And at home, we might have direct connectivity with the operator's network, or we might have a private segment, which is typically a Wi-Fi, right? Which also creates complications, right? So this is the access scenario, which is where most problems appear, but it's not the only place where problems appear, right? So this is very sparse in the network, and it needs to be connected through a backhaul network to the core of the network. I mean, the places that don't switch down when we have one day power outage, as we did in Spain. So which is like the UPF, so the final of the core function in the 5G network, or the equivalent brass in fiber. And the thing is that actually this, I mean, from here to here, what we have is really a private network. So it's IP, but it has its own IP address, its own tunnels, and things like that. So not much control from the application. Everything is under control of the network, right? And then here to the right, we have, let's say, the internet, right? The internet in the domain of the operator, and then some peering connections with the other operators. So to the kind of the rest of the internet, right? So the operator, the CSP, can do something here, and this might be also a critical point, right? So most critical points is typically the access, and this is something to consider. Some, depending on, I mean, there are some base stations which may have some problems in the backhaul connection because maybe they are connected with a microwave to the network, and then, you know, in bad weather conditions, there could be problems. And well, in general, bottlenecks are in that part, but sometimes, especially peak hours, there might be also problems in the peering for high demand content. So this is like a high level view of the network, but okay, maybe sufficient so that you can, if you are not in the networking part, you have a view of like the first layer of complexity that you will find in practice. So that's a bit of the landscape. So how we are picking our networks and our content, and then into the content of the documents. I will also cover this chapter and then hand over to Francois and David for the other two main ones, right? So we started with definitions, right? And it might sound not so important, but you found that in practice it is. And in practice it is because, you know, first definition that we have is the quality of experience. We have copied the Qualinet developed. I'm not sure because there's slightly different versions between Qualinet and ITU and whatever, but basically QoE is a degree of delight or annoyance of the user of an application or service, right? So we kind of agree on that. But when we go to the, you know, network operators, let's say, and we talk about QoE, they don't care really about that. They use QoE as, you know, the quality of my data. We had this conversation one year ago. So it's I basically need a cost function to optimize my network, right? So how can we jump from the user delight or annoyance to a cost function, right? So it's a big gap. So we had a lot of discussions on that, and we kind of set the point into basically what we do when we do like P910 tests, right? So ACR tests. So we kind of try to define this measure, which after a lot of iterations and mostly with the help of Camille, so it's good to have a psychologist in your team, we have this user-reported QoE as the term, and the definition as the quantification of the impact of a system in the user delight or annoyance that we can measure through self-report behavioral or psychological studies. And this impact can be caused by the application, network, or hardware, and is moderated by the usage context. And that's important because it kind of summarizes what we measure and and also what we expect to change to find some, you know, independent variables basically which moderate which affect what we measure, right? So this is what we target somehow. And actually, when we talk about QoE across the document, we'll mostly be covering this. This has some other, you know, implications. So user reported or in general QE metric is basically a statistical representation of this report. So basically, typically the MOS, but there are other. So if we do, assess some scores and we take the mean, we have the MOS, but of course there are other statistical ways of processing this data. We can have the ratio of good or better, or poor or worse, and of course we can talk about outliers. And I mean, we've been talking about that for the last 2 days, so it's not simply or only the MOS, right? And then we have a model QoE, which is the output of a QoE model. So basically what we get when we have BMAF, which is a predicted version of a user-reported QoE metric. So in this case, BMAF is predicting DMOS, right? So a QoE model will consider some signals and parameters to predict a user-reported QoE. So these are kind of terms that we will use later on the document, but that we think that if we can also promote, it will help clarify outside this group, so in a wider community, to really speak about the same thing when we speak about QoE, right? Because there are lots of different things which are called QoE out there, right? And which refer to that. We have also we have also talked about how does it impact. So we have also seen this kind of a layered approach, so inspired of the OSI layer architecture. So the gray part. So previous slide is the user, right? So what we can get from a single user, right? So we can go down, let's say, to the network, right? So we can go from the KPI, which is basically a specific network layer metric, kind of close to the quality of service or measuring the quality of service, and something in the middle that we have named KQI. It's actually, well, not first time, it's mostly coming from Tobias Hosfeld's and other collaborators' research, which is basically the metrics that directly or indirectly reflect the overall quality, like, basically what you get when you measure at the application layer, right? So the coding bitrate or the, buffer stalling events or things like that. So this, and this way, and on top of that, if we don't consider a single user, but like the whole network or part of the network, we can talk about system QoE, which is basically the aggregated view of the quality across a whole system, which is the layer where we could talk about QoE fairness, for instance, or comparing how we delivered QoE across different users. So these are the definitions part, and this helps us kind of structure a bit the state of the art, and the rest of the chapter that I will cover quite briefly is a bit of structure in the state of the art and like putting the right pieces of standards, papers, and things in this classification so that it's easier to navigate for people who's not into this domain and really understand different things, right? So we are using this layered approach also across the rest of the document to refer to different types of metrics and constructs. Right? So system layer for group level QoE, user layer for individual perception or the modeling of the individual perception. The application layer is where we are obtaining these KQIs like buffering ratio or audio quality or bitrate. And in the network layers is where we obtain the KPIs that we measure, like throughput, jitter, or SNR or whatever, right? And this is like the complicated version of the last slide that I will not read, right? So this is, we are trying to get into more details in the document and see if we can really structure everything. This is not totally finished, but at least, anyway, too much information. So the rest of the chapter is trying to also go to the most relevant international standards mainly, and also some important like industrial standards, and put them in the right layer, let's say, so that people can, again, from outside can navigate a bit in the state of the art and see, okay, these are the right documents to look at. This is a bit of the summary of them. So we have divided them based on use cases, so video, audio, gaming, planning, and XR, basically, and we are trying to pinpoint the most relevant recommendations and classify them. and also try to discuss a bit, or provide some guidelines on how to read these documents to the reader, right? So this is a bit this part. So yeah, I mean I can mention them, but it's not totally finished in the document yet. But basically, things that you need to consider when you read or you use a model, or when you try to apply this to your use case, is how it incorporates the technical context and the user context. So how was the model developed for the same conditions that you want to apply it? What is the level of accuracy that you get from the model? What's considered in the model, what's not? What are the limitations? Something also very important, which is that some models and some metrics are absolute and other are relatives, both in how they measure things and also in what they're trained to, right? So there are things we try to predict most or demos, and it has implications. So it's something that we do need to take care about. Also, which kind of impairments are covered by the model, which kind of impairments are not covered by the model, and which other context factors you should care about. So this is basically the overall, the first big chapter of the document. So trying to structure a bit the standard, the state of the art for the reader, so that we have a document that we can basically send to our, to our people in the CAPs, in the CSPs, in the research community, people who's not QoE expert, and they can read and understand the basics and navigate through the complexity in a reasonable way. I don't know if there we can leave questions to the end, or no questions so far.
Thank you, Pablo. When we started to do this work, we realized that the quality of experience is an end-to-end process. So we cannot just look at it from, we need to look at it as a system or an ecosystem, and we cannot optimize one piece only or another piece. We need to optimize at the end-to-end level. So we spend some time. In fact, the next two chapters are about how do you bring that collaboration among the ecosystem, what type of collaboration that should exist, and also what type of actions or controls that this ecosystem can take, and that will be the next chapter, and David will present that. We started to look at this QoE needs to be optimized end to end, and interestingly enough, optimizing a system end to end is easy when you control all the pieces, but we are now having generally the content providers obviously provides the content and control the devices generally. So they have kind of the extreme parts, and in the middle, the content providers, the communication service providers, telecom operators are in the middle. And we strongly believe that having these stakeholders collaborating and discussing what metrics, what to measure, is critical, because there is this concept of a lack of visibility. Generally, the content providers have good view at the application layer and above at the user layer about what type of service quality at the video quality or installs, bufferings, and so on. But we lack, as a content provider, visibility about the network. And conversely, the telecom operators are a bit, there is some opacity in verifying the quality that their network is providing at the higher level layer. So we strongly believe that by having some form of collaboration and potentially metric exchange between the members of that ecosystem will help each of the parties to deliver, optimize more effectively their section of the ecosystem. This is another representation that shows here the blue bubbles represents what is generally controlled by the content providers. As I said, on the client device, we would typically control, as a content provider, the type of encoding, some of the jitter buffering that we're going to use. The buffering on the right side the CDN, the content data network, where compute, storage, encoding, caching is done. And there are a number of potential impairments that could arise. Pablo alluded to that as well in the middle part, that having visibility of those potential impairments would benefit from, and the optimization. At the end of the day, we're trying to promote what we call a QoE aware management, or QoE management, where there is visibility that is provided across the ecosystem. So more visibility for the CSPs to understand what has been delivered to their customers, more visibility to the content provider to understand the health of that network. Is there congestion in that network that we should be aware? And potentially, maybe we will stream at the different bit rates and potentially change the codec. Efficiency, at the end of the day, the ecosystem will benefit from maximizing the resources utilization. Why stream and encode while we can't deliver because the network is congested? And also help, again, the operators to tune and optimize their network, because now they have a complete feedback loop. And fairness is also an important piece, as the traffic is generally encoded now and are encrypted, sorry. There is sometimes even our Facebook traffic as a video delivery, but sometimes it's mostly messaging and text. It's not obvious to know, should I optimize text delivery versus video delivery? But it's the same kind of a look and feel at the payload level. How do we make the classification more actionable? I'll pass it to David from Sweden, that will tell us more about some of the framework and the logics. Over to you,
thanks.
David.
Thank you. Hope you can hear me, and hope you are having a good day over on the West Coast. So yeah, we can. The next section in the white paper, we have trying to exemplify this, all the frameworks and the things that Pablo and Francois has been presenting already in 3 different use cases. You can switch to the next slide. Thank you, please. So, and here I will first try to present some of the concepts we've been talking about, like how we have tried to define different things, and then we'll show one of the examples that we've been using. So for all these, for all the services that Pablo listed in the beginning, we would like to have, as it says here, concrete metrics and models and tools for both data exchange and prediction and so on. And what we've been using when discussing this is this quality to resource curve. And you can consider this to be, for example, for a certain service, you have a quality to bitrate maybe, and the higher the bitrate is, usually you get better quality. But in some cases, these curves might not look as nice as this one looks to the right, but you can actually have with increasing bitrate, you get lower quality due to starting to getting congestion and so on. So these are the kind of parametricized models that we want to have to enable communication regarding the successfulness of a service between the CAPs and the CSPs. Yeah, I think you can switch to the next slide. So regarding the services we've been looking at, there are some general components and metrics that could be shared. Usually, a lot of these services they have some media fidelity component that we have to measure, both in video and audio. And here there are a couple of models already, and we sort of, I guess, all the CAPs working with this have some internal tools to measure this as well, if they want to have a service that people appreciate. there's also usually when you deliver media in this case, there's opportunity for stalls and freezes and drops. Depending on the kind of service you have, it will have different realizations, either as you know, the kind of YouTube rebufferings or shorter stalls in a conference service like this. And then finally, third area of components we've been talking about is this delay and interactivity part. For short-term videos, this is like how long it takes for your flow to update when you scroll around and interact with those videos. And for cloud gaming, for example, it's simply the latency it takes for your commands to reach the game rendering server and then be shown to you. So that's like the common group we've been talking about. Then this, we have tried to list them like, okay, we need these three groups of parameters and to describe the services. So what can the CAP do to provide information to the CSP and vice versa? Has a CSP, what information does it have that the CAP should be interested in knowing more about? And if you switch to the next slide, we have one thing we have proposed here in this in the white paper already is to have some kind of shared state table. I think it says here where we have like a combined database, you could call it, with both low-level metrics or application-level metrics that Pablo showed in that colorful graph, like bit rates and so on that are measured by the applications, but also quality of experience estimations, user-level metrics, and even what did we call them? Like group-level QE metrics on a larger scope, as well as maybe user level, like subscription data rate limits and so on. And then also network states. So that if we have that kind of shared state table continuously updated, or however it's realized, both the CSP and the CAP can make more informed adjustments and predictions to help the service be better. In this kind of database, it's also will be nice to have a lot of quality experience metrics, and we've shown the structure of the P1203 model here as one example of a sort of foundation structure on how to combine different media, for example, both in temporal and media aspects. Yeah, I can switch to the next slide, I think. And this is yeah, this is a lot of text, but I think it's still nice to show how we have talked about this for this short form video example. We have tried to list all the metrics we sort of could figure out that would be interested from both the CSP and CAP side, and divide it up into, as we mentioned before, in the different network layers where it's measured, and not even on only network but user sort of experience level as well. We have tried to figure out what kind of metrics there are, where there are existing models like VMAF and P1204.3 that can be used to measure video fidelity, audio models, buffering estimation indicators, and so on. How to blend this together, what kind of network states and metrics we want to and can report. We also tried to then define what are the reasonable timescales to do this in and useful, both from a what do you call it, blue sky wish list, like if we could dream this, then this would be what we want, but also then what is realized, what is reasonable to think that exists. talking a little bit how complex they are to provide, and then also listing where, let's say, who has the best opportunity to provide it. So this kind of list or table we made for all these, for the 3 services types that were the 3 examples. And this can be read more about in the white paper, of course. You can switch to the next one. Thanks. So I think this is the last slide for that. And we've tried to also then for these 3 examples show this how the flow should work. And of course it's slightly different depending on if you have a real-time service or like a cloud gaming on interactive service or teleconferencing where you have pretty quick turnaround, or for short form videos or even long form videos as the either other end of the scale maybe, where you download files basically instead. So the loop can be on different time scales, but we try to exemplify it here on both what kind of metrics that are needed, where they should be sent from and sent to, and who has sort of their responsibility in the different steps. And to show this in not only in tables, but also as flowcharts and like this one, for example. Yeah, do you have anything to add, Francois? Something I missed, maybe?
Thanks, David. I think this chart is, we wanted to test out, is this approach works on all the use cases? And also equally, if we were to make this ecosystem raise visibility, such as the metrics that are typically not seen by a stakeholder, either the CAPS or the CSP, if we make these metrics visible, what type of actions will each of the parties do, and what would be the impact overall for the customer, the end user? So that we wanted to, I guess, prove that this framework works on multiple services, and they are actionable control. So that was the intent of those flow diagram.
Yeah, exactly. Thanks for adding.
And in conclusion, the white paper, which is about 45 pages long, covers again, what are those definitions that make this align clarity on the definitions, metric, QoE, QoE what model, QoE user, QoE KPI, etc. So we wanted to make sure that the metrics or the definitions are clear. The framework and those shared state table that David presented are useful and are actionable. And the proposal now is to publish this, as Pablo mentioned, and work with some of the standardization bodies like ITU Study Group 12 to make some recommendations, formal recommendations into standards about some sections of this work. Ideally, we would like to do some kind of a trial, a mini experiment, make sure that these capabilities works and deliver value. So I think that's basically this work, and we're hopefully going to wrap up that maybe publish in the next month or so. Pablo, any closing remark before we?
No, I mean, that's all. We got a lot of people contributing, but it doesn't mean that we don't want more people to contribute. So we are happy for more people to read, comment, review, propose. The more eyes we have on the work, the better. So we can start now if you want.
And I'm going to add one more thing. It was an amazing collaborations between the industry. We had telecom operators, equipment vendors, and the academic researchers. Thanks to all of you that have been participating, and some of you are not here, but it was an amazing blend of different point of view, different, I guess, yeah. I was very happy to work in this. Thank you. Yanni?
Thank you to all really for the hard work here. So in the practical sense, I totally agree with Pablo. The more, let me say, strong names sign the paper, the better it is. So we already have very strong names, so I'm very happy already, but the more the merrier. What are your plans to do you have specific channels on specific potential people that can contribute, even just by reviewing and say, yes, we believe strongly in this one? I would say there should be perhaps two levels. The actual contributors to the work should get the most credit, but we should have another sort of endorsers or people who at least do not object to it. Because the last thing you want is to come up with a paper and then somebody says, oh, I disagree with this paper for A, B, C, D. So I would like us to have a plan that say, hey, we haven't reached out to Yanni, right? An imaginary other Yanni, who we think may have something to add or potentially to object. So at least clear the road to a quick, if nothing else, not necessarily adoption, but propagation of the message. Because I'm very keen to come up with a single document that has been thoroughly studied and again, either authored or endorsed. So when the time comes for somebody to present it, there is no argument, right? It is a de facto widely accepted white paper by the experts in this area.
So, I mean, I'll start and you can finish. So do you suggest that we release kind of a final draft for final comments to the group, the organizations that we think might be bringing other value before we release publicly at all?
Basically, that's what I'm saying, right? If you know there is a cap today that somehow for their own reasons, right? Either they never found out about it or they found out about it and said, no, we don't want to be involved. And that's perfectly understandable. At least can we give a heads up? Say, this is again a draft, final draft or tentative, however you're going to call it. As a courtesy, would you like to, if you say we don't want to give you feedback, that's also acceptable. But if you have something to comment, positive or negative, let us know now. Maybe we actually missed something, right? So you can improve it.
Yeah.
Or maybe, there's just a fundamental disagreement, so we know where that stands, right? So at least map the territory.
Yeah, we did a bit of that, but we need to do it in a more structured way. Yeah? So we already have, so when we went to ITU meeting in January, we already involved some people from study group 12 who are, the main rapporteurs of the groups who are not members of this, but we already have a first round of reviews from mostly the people from the industrial research community closer to the problem who are not authors, but could have a strong opinion on that. So at least a few of them, like the key ones have been already touched and read and informally agreed. But now that it's kind of more finished, we should probably do it in a more structured way.
I think when we started this, Pablo, you had mentioned that when we have something concrete, like a white paper or something document, it would be we should do another round. And I think that's what you're saying. Now we have something tangible, that we have a solid 40 pages. I think it's been good shape. It needs to be maybe tuned, but I think, thanks for your advice, Yanni.
And if I can just add to this, then we as in VQEG need to have a quote unquote marketing plan, right? We have this like gem, but if people don't know it's there, it's useless, right? So we need to have a specific campaign. It can start, for example, with LinkedIn. Since now have quite a few following on LinkedIn. Could be multiple venues, upcoming conferences, industrial events, where maybe individuals who are member of the group. So we need to start really, again, presenting, right, in suitable fora, receive further feedback, and maybe there is a revision after a year that's, hey, after we did a roadshow, right, we collected that we missed A, B, C, D from people that, just were never aware of it. So really, I invite the group to wrap up the work, because the meat is there, right? What you need now is the nice packaging and the bow on top of it, so people will buy it, okay?
Any questions? Patrick?
No, to add on top of that, I think, I'm not sure if it's the case right now, but you should make anything possible to get a DOI for this document.
You know what is a DOI, right? So, yeah.
Yeah. So any plans to get this or not?
Not yet. What we haven't. So next two big steps is, we wanted to finish the content, and we had, this next two big things, open things, is how to review and how to publish. Yeah, but fair point, because we haven't even started discussing that.
Yeah,
So
yeah, because you know why? Because once you get the DOI, then it will go immediately cited in some papers, which is another tribune and a way to put visibility on this work in addition to LinkedIn and stuff like that. So yeah.
fair point. Maybe something for tomorrow, Yanni, is if as VQEG we can publish a white paper and get a DOI.
Let's add it to the agenda or a mental agenda for tomorrow's administrative meeting. But
So what we do with it? I mean, how do we publish this?
Exactly.
Can we produce documents? Must
how from
else-
internal becomes external, basically,
that's
right? And publicly, and announcements, maybe peer, maybe a press release or something.
Yeah, actually, this is a very good idea to be either through the platform of the VQEG. Otherwise, if you need outside as well, that I can help as well. Maybe we can discuss offline. We can get this ISSN number through our university as well. Like there is some way that we can get it over there, but we will discuss that one. What is the best way?
Okay.
Yeah, it was a small comment on that. So it was not explicitly like debated, but we kind of see that this is a VQEG white paper, and it might not be the only one, right? So there are other things that have been discussed these days about, the all this framework for the usage of metrics and things like that. So there's a lot of knowledge that VQEG is putting together. So we should have a way, or it would be good to have a way, in my opinion, to publish this as VQEG, kind of homogeneously, right? So don't need to reinvent the wheel each time we do something like this.
Thank you.
Yes, thank you for a very nice presentation. Really appreciate it. Yeah, I had one comment when you say the system QE. Didn't quite capture. I didn't quite get what you meant there. But one thing I have in mind is it like you talked about aggregating across the users. One thing we talk about is the utility of the QE that we offer. Maybe that's something that's naturally aggregated, whereas QE maybe there's a minimum level where you don't get really much value out of it. So I don't know if that's what you capture, or I mean, also I'm thinking of different QE dimensions, capturing that. Maybe you want to comment on that.
So what we try to capture here is the idea that so anything related to handle or optimize QoE simultaneously for the whole system, or for a large number of, or sufficient number of users, let's say. So which means that kind of how to it's backed with some works on the like a research community, which is not a very big topic. So there's not many people working on that, but there's some theory about that, and some of the authors are here about how should we care about, for instance, fairness in a QoE proper way, or how should we think about the distribution of the QoE across the system, things like that. So this is kind of the concept, but beyond the concept, we are not really addressing anything related system QoE in the white paper, right? Except kind of defining and pointing maybe some related concepts. So if there are others, there might be there, right? So these kind of things are in the same domain, right? But we are not really going deeper into that domain in the white paper.
Thank you. Yeah, one more comment I had was on the time scale. Maybe we want to specify the sort of the reportings, time of the reporting intervals. It could also be like push-pull type of model, right? Like in some quick changes, maybe you want to push a change, otherwise pull. And also the more details about something like latency. How do we report this? Is it the percentile? Is it the histogram type of data? That might be good to capture as well in this table.
Yeah, in terms of time scale, we kind of analyze different time scales. So basically, it's in the white paper a bit that we might think about like short-term time scale so that management can be done. So you can react like mid-term time scale. So it's about things happen. So I want to understand what has happened, like a long-term time scale, which is planning basically. So and among these three, we are focusing, like in the example level, we are focusing in the short term. So we are trying to attack that first, just to start by something.
But you're right that from the operator's perspective, there is some long-term planning by having visibility in the QoE that were achieved over a week, over a month. Maybe that area, geographical area coverage might need some kind of improvement or antenna changes and so on, and this type of feedback. But also conversely, ideally if we can have a fast feedback loop as well in a session that is happening as we speak, what kind of a simple thing that could be exchanged to give some cues and so on. Any other questions?
Yep. Have you considered presenting it as like another standardization for as VQEG, so not as persons, but as the group? Like one thing I have in mind is for example IETF, ICCRG, where IETF is pretty pushing back on all kind of direct application network collaboration. There is an example right now when they are not, but there's a long history of pushbacks there, and somehow trying to convince them that talking more about this makes sense, and presenting as a fora as opposed to like companies. I think that would make a lot of sense.
We recently joined forces on SCONE, which is a kind of a protocol to exchange information between. So maybe that might be a way that we can present, call it SCONE 2.0. This is, by the way, what we could do as well, and maybe that's an entry point. But your point is also valid that IETF has not been generally speaking the QoE forum. So we thought we would start with the ITU study group 12, but that's a good idea.
Okay.
And of course, our team is going to have lots of questions. We'll have a lot more interactions with you guys going forward. We've been busy for the last few months working on grant stuff, and sorry about that. And we work with David a lot, so we'll probably work through David a lot of the time. Like just as a comment, it's great. I'm so glad that we're finding this alignment. You know, finally, maybe it's been 20 years. People have been talking about this sort of thing happening, right? One thing about the KPI exchange and kind of the timeframes or the control cycle times and things like that, at some point we'd really kind of see trying to be a little bit more declarative about that, where the application would be able to push in some like utility curves or other specifications of what are the right trade-offs that the network can make that would positively help the application. That doesn't take a whole round trip time in order to be able to have a sort of a control cycle, if you will. And so so starting with the KPIs is absolutely great, especially for like some lab testing. We can dig into the details. But as far as in actual deployment, a lot of the online actual communication, we might be able to distill down into kind of a declarative format, like I said before. So ways to express the bit rate versus temporal or jitter types of trade-offs that the base station is really good at making if you give it the information.
That was one of the feedback from AT&T as being one of the collaborator in this, and that was their feedback as well, that yes, it's nice to have the QoE one value, but what is a QoE at different bit rates or a mask score at different bit rates? So having those rate distortion curves allows the operators to make trade-off. If I increase the bandwidth, will I reach that plateau? Should or can I go down? So I think that is it what you're.
It's related. So yeah, I mean, for sure, if the base station, the network understands the relative QE value of certain bit rates across all of the different users, we can manage the bottleneck, the RAN, in a very QE intelligent way, right? Maximize the aggregate QE. That's one step. But also, there's a natural kind of set of trade-offs. If somebody is willing to accept a little bit more delay, we can give them more throughput for various scheduling efficiency reasons and stuff like that. And the applications, I think, would really benefit by saying, this is short form video, but I don't care about the difference between 50 milliseconds and 100 milliseconds. If you tell us that, we can be a little bit more efficient versus like if it was real-time video and you really do care about the difference between 10 milliseconds and 50 milliseconds, the amount of throughput we might give you for the same resource cost is a little different, right? But we'd be able to meet your jitter requirement.
That's very, very good input.
Yeah.
Yes.
Okay, and there's probably so much that we should talk about, and maybe I shouldn't do it all here, right? So maybe we'll follow up.
Thank you for your feedback.
And one more maybe suggestion. I think that sometimes people nowadays do not read 45 pages, unfortunately. They sometimes don't read 45 words, right? So, of course, a very concise, abstract, I still call it abstract, everybody else calls it TLDR, is critical. So take as much time as you need as a group, but carve out a message that can be captured in, I don't know now how many words is the next message, right? 300, whatever. First comment. Second comment, if we can put together one CAP on a volunteer basis with one operator that will take, say, the learnings, put them in a test demo platform that says, hey, this is what's happening today before we talk to each other. This is what happens tomorrow when we talk to each other, right? And hopefully something that's going to be, oh my God, this is so much better for me, the operator. I'm saving X in whatever units. So how much I'm saving Y as in CAP? I'm in whatever metrics I'm using. And how much I'm saving as or improving as Z, the user. So then the proof is in the pudding. So a short video that shows before and after, like the usual, would be really good for, if nothing else, allow me to use the term again, marketing purposes, right? For people who will not read the paper, who will not even read the abstract, but they will say, imagine now you are a top exec in companies, whatever, say, and you talk to yourself, I want this in my network, or I'm a CAP and I say, oh, I want this to be implemented tomorrow. So think ahead of a demo platform, right? Think what's the best format to do it, but pick one partner, pick one for the gear in between, right? Pick somebody and then coordinate a demo.
Thank you, Yanni. We had put that in our conclusion, and yes, you're absolutely right. Having a white paper is great, but having also a field trial or prototype, it's another level of, I guess, achievement. So thanks for confirming that.
And when it comes to something like that, we are not quite there yet, like in our group, but we published a few papers. Like we published a paper last year. We have a paper under publication that's kind of tries to show how to do it and what are the gains. It's not yet like a demo, but it's a way towards how to set up such a.
So you raise your hand to be partners? Okay.
I mean, we are involved through David.
Very good. Very good.
He's directly involved in the second paper, and he was a lot of help in the first paper.
I think this is all good news. And again, thank you. Back to you.
Thank you.
Thank you. The other presentation is also mine, so you will. Maybe I can log this. I already logged on the Zoom, so maybe it's the easiest.
You want to do the HDMI or?
Is the HDMI better? Maybe?
Well, it's easier, but some people have issues before. But...
Okay, good. So so I'm presenting something, a model that we have done a bit to address this topic internally, right? In our team in Nokia. It's not totally, I cannot sell it as a Nokia model yet, but we are promoting it internally, but at least it's what we are doing in the lab, right? And yeah, these are the main authors of this, including Camille, who spent last year helping us building this model as well. And let's start with the motivation, right? So we know that there's big, very complex or successful models in the literature, right? To model and manage QE in theory, but in practice, when you go to the networks, people rely on simple things, right? So there we have P131203, whatever, but then we put a cost model in a paper and we find something like, I will do a linear combination of 5 KPIs rated with a bit of arbitrary values. And not to, not to blame anyone, I'm also a co-author of that paper, right? So this is something that happens when you need to work with networking people that you cannot afford, the complexity that we sometimes manage here. So what we try to do is design a simple model that we can handle ourselves, that should be, simple to use, but ideally better grounded on the state of the art, right? So I have first a few slides on the design principles and assumptions we have taken to design this model. There's a lot of meat in each of the slides, and I'm going to be quick. So I'm not going into any detail, right? So stop me or ask me later or in the coffee if you want to discuss, because it's kind of summarizing what we based to build the model. So first idea, we're in a network. We need to have something where we can plug any use case in. It's easily, right? So new use case comes, I can plug in a new model. I don't need to have a 2-year cycle of research to put a model for the new use case. It would not work. Based on that, simple models are preferred. This is parsimony. Thanks for Camille to helping us kind of structuring this part of the conceptualization. So basically, let's start top down. So instead of figuring out all the possible combinations of factors and distill them, let's start with the simplest, most important factors, and then add complexity once the simple model is controlled, right? So second idea. Third idea, we are focused in user-reported QoE in ACR scale. This is what we care about. And fortunately, I had the opportunity to define it in the previous presentation, so I will not stop here. Okay, why? Because this is an assumption. It's not totally proved by the literature, but this is probably the strongest assumption of our approach. This is the bridge between the network, the quality of service, the factors that we can control, and technology acceptance. So ultimately, the user acceptance of the technology, which means that basically the QoE as ACR measurement is only a small part of the whole, landscape which will make the user accept the technology or not. But it is the part which captures everything that we can control in the network. Right? So if we measure ACR, we somehow have enough information about the network, the source. We can forget about that. We know the ACR value. We can think later on the acceptability. So we can kind of break the relationship between the system, the communication systems, and the user based on this metric. So this is why it is so important for us. Properties of this metric. So why this is good? First, people is robust in judging the quality on ACR scale. So basically, you can do any kind of ACR tests, and you more or less always get the same results at lab, at home, at whatever. So it's really, really robust. There's some small variations depending on the, you might get some small variations depending on the content type, the user mood, or whatever. But if they exist, they're small. So it's a magnitude which is kind of robust. And yeah, if you have doubts about that, again, Camille has done a whole PhD thesis on the topic, so ask him. He will be happy to answer for sure. And the final property, thanks Shell for raising it a few years ago in Quomex, right? My first Quomex meeting, by the way, VQEG meeting, by the way. We are basing all our models in measurements, like in user tests, which have a lot of uncertainty, right? Because roughly speaking, you can do a lot of statistics, but roughly speaking, for a typical use case that we have 20-something users, whatever, we will not get a resolution which is higher than like 10% of the scale. Big numbers, right? So if we are able to handle the order of magnitude of the problem, we are in the right direction. And later on, okay, we might do fine-grained tuning, but this is kind of the uncertainty that we handle with even in our input data, right? So maybe it's not so important to go to the fine-grained for many use cases, right? Something I presented 2 years ago as well here is that we can model it reasonably. We can model these scores as a normal distribution with constant variance. Most important thing here is that these scores are based on its experiment, let's say. So opinion scores are always based on a context where they were measured, right? So there's no most equal to 3 in the wild. It will always depend on, the context, the screen size, the type of content that you put in the test, something like that. So, but given experiments, you can have this simple model that in a continuous scale, you could model the distribution more or less for a single experiment with a normal distribution with constant variance of the scores for the whole experiment. It's not perfect, but it holds. It's actually the equivalent to the source hypothesis that Tobias presented a couple of years ago. And it helps also build some simple logistic mapping between this continuous scale mu and the measure scale MOS, which actually, goes to a very old concept of the QoE, 50 years ago, which was this transmission rating scale, how things started when people started to develop metrics in the 70s. But the thing is that, again, for the level of resolution that we want, this linearized scale is a good way to linearly, so this scale is a good way to linearly map the results of 2 different experiments in different contexts. So things hold reasonably well there. This is kind of an assumption backed by it's not a proof, but it's a design assumption backed with what we know, which means that we could also even define a reference context, which is whatever, but we can call it transmission rating for historical reasons. And then we map our MOS, in this case, linearly to that context. And finally, we know that so if we have this rate, this resource versus quality curves that David presented in the last slides. So this is kind of equivalent to single dimension QoS to QoE mapping, let's say. And we know that they can be approximated with simple models. I did a quick test to taking some complex parametric models and comparing them with simply the delay in milliseconds or the log of the bit rate as a metric, and then tune a bit, the mapping of just using 2 parameters, so a linear mapping, and then you have like decent results. So basically, if you can have a reasonable approximation of this curve for many use cases, just by kind of monitoring some basic metric and having defining the thresholds where you have to move. So basically the acceptance and basically the perceptual threshold. So basically anything on top of that, I don't perceive the difference, and I can kind of arbitrarily assign it to the MOS 4.5, but we could use different numbers. And the acceptance threshold, so anything in the bitrate below that is not accepted. I could put it at 3, but again, it could be switched something else. I'm not saying that, of course, that models that BMAF are useless, because they basically provide the context, right? So, but they basically provide this acceptance and perceptual levels for each content, which is, critical. But if you don't have a model for that, okay, you maybe could ask the user each time or whatever. So figure out or have an average and start working with that, right? And finally, also backed on the research, is that in most cases you can have multimodal scores. So basically, audiovisual quality can be quite well predicted if you measure visual quality and audio quality. There's works on that. One very good from Milene a couple of years ago, or more than couple. How time flies. And yeah, so basically we can this way kind of divide a bit the problem to simplify it, right? So based on that, this is how we are building our model that we want to test for our XR use cases mostly, but ideally for anything that we try to do ourselves, which looks like this, right? So basically, let's assume that, so this could be like a multi-party conference of any kind. So let's say for each point-to-point communication, I will always be in the point of view of the receiver. So I will be the receiver, and I will receive feedback from some source. So I will have some video, some audio, some synchronization for that source. So I will have a score for the video, a score for the audio, score for the synchronization, a score for anything else. I will blend it with a multimodal QoE. This will be like the point-to-point QoE, and then I could blend with other point-to-point QoEs to have the multi-point QoE. So this is like the architecture of the model. So single stream, basically, we try to go this two-level step of go in R scale and then in MOS scale. If we have a model, we use it, right? I put BMAF an example. It doesn't need to be BMAF, right? So if we know video quality, we use it. If we know video quality, but the model is in different contexts, then we can adapt the context probably based on handling the right thresholds on each of the contexts so that we can map. This is basically what BMAF does for the BMAF mobile, right? So we did not really invented that. And if we don't have the model, we have some tools to create one based on simple QoS to QoE mapping, right? For which case we should have per context or content thresholds. And then we aggregate the scores individually using weighted Minkowski mean, which is a good way to say we don't really know which kind of mean to use, so let's use the most general one, which only will depend on one parameter, right? So for the multimodal QoE, this parameter is 0 normally, because most papers say that weighted geometric mean is probably the right way to map video and audio in MOS scale, right? For multi-point QoE, the thing is that we can do experiments or even design it, right? So basically, what does this P in the Minkowski mean? It means that it will be more optimistic or pessimistic, right? So we have some curves. You don't see the numbers, but don't care too much. Basically, the blue curve is we have five scores and one score, and the red one is the opposite. We have 5 1 scores and 1 5 scores. So we have extreme values. So let's take the blue one. What happened? Everyone is happy except one user who is very unhappy. So if we take the average mean, MOS will be 4.3, okay? That might be our situation, but maybe this is not a good reflection of our service. So if one user is happy, maybe the MOS should be like the geometric mean, so something around 3 dot something, or the harmonic mean, so it should be a 3, or even worse than that, because we don't know any single user to be, I mean, a single unhappy user will make our metric down. So we can characterize that for each service individually, and it's a single parameter basically. And there could be weights if users are not symmetrical, right? So in a presentation, for instance, there might be a presenter and other users, so we can assign different weights. In other use cases which are symmetrical, they can assign different things. And the idea here is that the model is modular. So what we should do is basically parameterize each part independently, right? So let's parameterize the video test. So let's do video test only for the video, audio test only for the audio, or combining good video and bad audio qualities to rate to understand how they combine each other, right? But forgetting about measuring video or audio at that moment. So if we do one experiment at a time, we can probably start. So there's an implicit assumption of independency of things below, but that again we take because we are only caring about the first order of magnitude problem, right? So simple test based on P920. Fortunately, P920 also defines the 4 protocol that we spent some time developing a few years ago, which means that we can bootstrap some of these parameters with 4 to 6 users, which might even be experts, performing the assessment 4 or 5 times in different days, which means basically that you can gather your team, create your test, run the test 5 times in your team, get some numbers, and use your initial guess of the values, right? So this is how we have designed the whole thing, right? So this is how it is. Caveats, or you know, known limitations. Let's say it's for a single user, which is in the receiver position. So if you want to pull across different users, you need to understand system QoE. So basically read all Tobias system QoE papers and apply the reasonable metrics. It's instantaneous quality, so we are not pulling across time. We are not accounting for recency, peak effects, things like that. If we want to do that, okay, there are also papers. There are also caveats, right? We did some experiments that Marta presented a couple of years ago that things start to interact weirdly when you ask people at the end the quality, because you start moving away from perception to perception and memory, and then we are in a different domain. So, okay. But for some situations, we don't even need to care too much about that. And that's almost all. So key advantages that for the system, that it's a simple model, but it's explainable, it's modular, and it can be bootstrapped by the design team. So basically our next step is looking at our own systems and everything that we have in the lab and trying to develop our own model for our own stuff. This is basically the main target of the model, basically, actually, but anyone could do a similar way. And also it's a nice approach. We think it's a nice approach for experiments in general, right? So it's probably a nice approach to try to address complex things in a simpler way. Like, so multi-party, there's very few multi-party subjective experiments, probably because we are trying to measure a lot of things simultaneously. Maybe if we break the problem in smaller pieces, we could start developing models. And yeah, well, that's almost all. A bit of publicity. So as I hope you all know, next COMEX will be held. It will be in Madrid in September. You're still on time to send a short paper in June. Short paper is very short, 3 pages. So we accept any. We don't accept anything. I mean, there's a review, but I mean, it can be results. It can be a positioning paper. It can be an opinion piece. It can be everything. So I mean, in terms of type of content, anything is possible. So please consider sending a paper if you haven't, and of course, visiting us in Madrid, because it's a nice time of the year. And that's all. Thank you. Comments, questions? Or do you need a lot of coffee?
It's this, late afternoon type of.
Yeah.
But any questions? I mean, just a comment from me. I think it's also in the original dynamic optimizer blog. We have found time and again that harmonic averaging, which inherently is more biased towards lower numbers, tends to work better when it comes to a better aggregation method, right? So I'm always a strong believer that, and we can have a discussion over coffee more extended, but the gist of it is we tend to average qualities, right? Even talking about very simple things like calculating PSNR, right? The standard way that I've seen in most of the literature is to take the PSNR of every frame and average and then divide. While we should be averaging distortions. And if you do the two, different numbers come out, which eventually boils down to how you do your averaging. And I always believe that at least in systems where impairments are additive, but not qualities. So therefore, I very much, yes, we're very familiar, right? And all it needs, you can go either to L infinity or L0 for the two extremes. And thus, I really believe that this is a nuance that somehow is missed in not just this application, but in general in our field. So thank you for highlighting this.
Yeah, thanks. Yeah, I mean, it was a bit quick, but actually adding so let's say it's kind of here. So it's a bit in the state of the art, but in very old paper. So we need to figure out if there still holds. But there's some kind of agreement that the right way to add effects that go over the same medium, like effects on video or on audio isolatedly, is basically adding or subtracting the effect of the different impairments. So that's kind of implicitly in some of these slides. However, yeah, and it works reasonably well in this R scale because it's not bounded, right? So then you then can put the numbers of the thresholds and things hold, right? And we actually had a lot of discussions on whether we should do the audio-visual merging, this kind of merging at that level as well, we thought that it was better to do it in the most domain and therefore probably going to geometric main. Well, first of all, because it was kind of backed by the most recent state of the art, which is also strong, reason. And secondly, because we thought that it probably follows better the way of thinking that I think, okay, I rate this video as bad, I rate this audio as good, so I then will rate the audiovisual quality as 4. So it will, mentally, we thought that it was better to consider that audiovisual merging happened after you have rated the video and the audio kind of in mind. And there, apparently, geometric seems to be a better option according to the state of the art for that particular thing. It's also in line with, it's also kind of in line with the result that VQEG had on the multimedia or the audiovisual quality merging a few years ago that Margaret presents from time to time.
Comment related to averaging, also disaveraging, but also in the previous the system QE, like what kind of like we tried to average QE among users, and it didn't, for at least me, made a lot of sense. So maybe moving these QEs to kind of like another domain and doing the averaging in that domain, like for example the utility domain, maybe makes more sense when it comes like, and that's kind of, I kind of feel that true for both system level QE averaging, but also like multi-party conversations, because at the end of the day, like there is not a single QE measure anymore because there are more than one user. So what you're interested in is kind of like the value you created for those 5 people. And that's maybe like, maybe it should be a different kind of measure, not this measure anymore.
Yes, I mean, it's a great point. Yeah. So there are 2 different ways of seeing it. So, well, to be clear, when we're talking about multi-party, it's multi-party, but from the point of view of one single user, right? So at the end of the day, it's good to have a metric because then we can optimize the experience of this user if we can measure and manipulate the network in real time, right? So having a number is good for the purposes where you need a number, right? But on the other hand, I also agree that eventually, so, and it's a very valid point, that there's a limit on where you can reach in the QoE, right? So there's a limit on what you can actually go just by asking people 1 to 5, right? So, and there's a moment where you need to really leave that domain and start thinking on people, right? On humans, so giving value and stuff like that. And maybe the aggregation of users is a moment where we should already leave that domain and try different frameworks, right? So that's a very valid, thank you for the point.
Are we wrapping up?
Yeah, so that's the final, I mean, this, we end the session of the 5G KPI, and I don't control the agenda, but I think it's time for break, maybe?
It is the favorite time of the day. So we have 3 minutes extra, everybody, okay? 1 more sip of coffee. So coffee break until 3:30, and we can stop the recording.